The first diagram consists of a simulation of net force. We need to remember that net force is the total force acting on an object by adding all its individual forces as vectors. In this first simulation, we can observe if forces are balanced. When forces are balanced, this occurs when all forces applied on an object are equal. When this happens, the forces cancel out each other, and the net force is zero. So the object's motion does not change. Another example is when forces are unbalanced. This other example it's an example of unbalanced forces. This occurs when forces do not cancel each other out because they have different magnitudes. When this happens, the net force is non-zero, and the object accelerates in the direction of the net force. When we talk about net force, we can observe that a larger net force results in a larger acceleration. This is expressed in as F equals ma, which is stated in Newton's second law of motion, that obtains that amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the body. This second simulator is about movement. Our situation is a skateboard uses our base, and a man is standing right next to it that exerts our desired force in a desired direction. This simulator is an example of Newton's first law that states that a body remains at rest or at the uniform motion will remain at that state unless an external force that is being applied in this case is acted upon a body. Also, a formula states that the heavier the body is, in which we are exerting the force, is the smaller the acceleration it will have compared to a light body. This is because heavier objects have more mass and greater inertia, meaning they resist changes in motion more strongly. They demand more applied force to achieve the same acceleration, but it's also harder to stop them once they are in motion. So the heavier the object, the lighter the object, the faster it will be. At this case, we can see. But if I apply 200 kilograms, then it will be much more slower than it was. And if only I put 40 kilograms, then the object is gonna move really fast. This third simulator is focused on inertia. Inertia is defined as the resistance of a body to change in its speed of motion, in this case. And it happens when two surfaces are in contact. Occurs only when they slide or roll against each other, and is affected by factors like surface roughness. It is also affected by the body's weight. In this case, we can see that the speed is decreasing because the object weighs it's more. And the type of friction, obviously, is static or kinetic. These changes in motion are also stated in Newton's first law. In sum of forces, and in these examples on a flat surface, we know that normal force is proportional to the weight of the body. So the stronger the normal force is, the stronger the interaction between the surfaces at the microscopic level are. As a result, this leads to more resistance. Acceleration is the change in an object's speed or direction, and it only happens when a net force acts on the object. In this case, we're going to see if this accelerates. On Newton's first law says that without an unbalanced force, an object will not accelerate. Forces here are unbalanced, so we're going to apply greater force to the left. So the object starts accelerating. Newton's second law explains that acceleration depends on the size of the net force and the mass of the object. And Newton's third law states that forces comes in pairs, but the acceleration of an object comes from the net force acting on it. In simple terms, acceleration is what results when forces on an object are not balanced. Here they are unbalanced, but if I apply here a body, the speed will start to decrease because the forces are being balanced. If I add another object, there's much more force of friction because the object is heavier. But if I apply like the normal in here, then it will start accelerating again. In conclusion, friction, the sum of forces, acceleration, Newton's law all work together to explain how objects move. Friction resists motion. The net force determines whether the motion changes, or and acceleration shows how the change happens. Newton's laws tie everything together by describing how forces act and how motion rebounds. Understanding these ideas gives us a clear picture of why objects speed up, slow down, or stay still in the world around us.